We already saw the previous examples that rational exponents are very closely related to these surds. So we can write a surd in exponential notation, because after that we can easily put into action the exponential laws. So what are the additional laws? If we are an intent to simplify the surds, this is if you have nth root of say x and you have nth root of say y. What does this mean? This is simply x to the power 1 by n, and this is y to the power 1 by n. And since the power are same, we can apply the exponential law and we can combine these together, x, y to the power 1 by n. 1 by n. So this is again nth root of x, y. This is what is shown here. Nth root of a, nth root of b, this is nth root of ab. Again same thing, if nth root of a by b is there, that is simply this means ab nth root is there, that means this is a by b 1 by n. So this can be applied to both of these, a 1 by n and a 1 by n, b 1 by n, and this is going to be nth root of a and nth root of b. When we have this m and a, mth root of nth root of a, that is this can be written as, let me first write like this only. So this can be written as what? 1 by m. So nth root of a to the power 1 by m, or raised to power 1 by m. Now this can be written as what? A raised to the power 1 by n, and this already has this 1 by m. So ultimately what we get? 1 by m, 1 by nm, because 1 by n into 1 by m is 1 by nm. So this is a by 1 by nm. So this is simply nm under root a. When we have this kind of thing, n a by m, this is going to be equal to a by m, and I am taking this as raised power 1 by n. Now this is m into 1 by n, m into 1 by n, that is m by n only. This is going to be a by m by n. What is this? Nth root of a to the power m. This simply means the same thing. Why? Because this is a to the power 1 by n, this one, and to the power m here. So m into 1 by n, this one is m by n. So this is simply a to the power m by n. Let us take an example of this. As I already explained these two to you, so we'll just proceed to the next one with an example, actual example. So we have this root 2 into root 32. So root 2 into root 32. Root 2 can be written as 2 to the power half, and 32 can be written as 32 to the power, or you can say raised to the power 1 by 2. Now see, the powers are same, so you can just combine this. 2 into 32, you can combine this and put just one power 1 by 2. This is 64. 64 to the power 1 by 2, that is root of 64, that is 8. Here also, this is 24 raised to the power 1 by 3 divided by 3 raised to the power 1 by 3, and this is simply 25 4 by 3 raised to the power 1 by 3, and this is 8. 8 raised to the power 3. 8 can be written as 2 cube. So 2 cube raised to the power 1 by 3. So 3 into, this is 3 into 1 by 3. This is 1. So you get 2 to the power 1. So 2 is the answer. Root of 81. Root of 81. So this is 2 and this is 2. So 2 into 2 is 4. How does it come? See, we have root of 81. That is 81 to the power half. And then again we have root of all these. So again we have half of this. So half and half is 1 by 4. 81 to the power 1 by 4. So 4th root of 81 we have to find out. But 81 can be written as 3 to the power 4. And we already have 1 to the power 4. So 4 into 1 by 4 is what? 4 into 1 by 4 is 1. We get 3. What are like and unlike surds? If you see, we have this nth or mth root, or you can say a raised to the power 1 by m and a raised to the b raised to the power 1 by n. So if this m and n are equal, then we say they are like surds. That is, if you take an example of under root 1 by 3, this is 2. Also under root 61, this is also 2. So the root is same or the raised power is same, that is why these are like surds. But here the raised power is 1 by 3, here the raised power is 1 by 5. That is, this is 5 raised to the power 1 by 3 and this is 7y cube raised to the power 1 by 5. So these are not same, so they are unlike surds. And what we can do here is we can write the simplest surd form. That is, if you have n a b, we can always write it as we have already seen, that a b and nth root. So this is how we can write. I'll take an example of this. Write the following in the simplest surd form. So how to write this as simplest surd form? Under root 50. First we will write the radicand as product of prime factors. So how we are going to find out the prime factors? 50. So let us take from 2. 2 25s are 50. Then we take 5. 5 5s are 25. So we have 2 5 5. These are the prime factors. So we can write it as 2 into 5 into 5. So 50 can be written as 2 into 5 into 5, and root 50 means 2 into 5 into 5. And we will now simplify using this. N under root AB is n under root A and n under root B. This is not root actually, it's mth root and this is nth root and nth root. So how we are going to write this? We'll separate these two out and these two out. This one out. This is 2 raised to the power 1 and this is 5 raised to the power 2. And this is simply under root, but this is 2. So this will be, we are taking this one, first one, that is 2 under root, and then this one 5 square under root. I'm just writing 2 just to show you that it is 2, otherwise it is well known that this is square root only. So this will remain as root 2, right? Because 2 raised to the power half, again nothing is cancelling out, so it is already in its simplest form. How about this one, 5 square, and then we have this root, so just raise it to the power 2. 2 into half, that is 2 into 1 by 2 is what? 1. So this is 5. So you have 5 root 2 as the simplification of the surds. But sometimes the surd cannot be simplified because they are already in the simplest form. Let us take an example of this one. This is the third root of 54. So let us find out first of all the prime factors. So it is 2, 2 2s are 4, 2 7s are 14. Now 3 9 is 27 and 3 3s are 9. So we can write it as 2 into 3 into 3 into 3, that is 2 raised to the power 1 and 3 raised to the power 3, and this is third root. So I am taking them separately, that is 3, this is third root of 2 and third root of 3 cube. This will give us what? 3 cube, and I can raise it to the power 3, and you already know 3 into 1 by 3 is what? 1. This is going to give me 3, and this is third root of 2. So this is the answer. Simplification. One more example, under root of 147 and under root of 108. So I'll show it to you here only. 147 can be written as 49 into 3. 49 into 3, 49 multiplied by 3 is 147. 108 can be written as 108 as 36 into 3. So now 49 can be written as 7 square, 36 can be written as 6 square. Now we can separate them out. How we can separate them out? See, this can be written as 7 square to the power half, and this can be written as, don't need to write as power because it will be root 3 only. This is 6 square to the power half, that is root of 6 square. I'm writing this again as root 3. This 2 cancels, so it will be 7 root 3. This 2 cancels, so it will be only 6 root 3. See, 7 root 3 and 6 root 3. There are two methods to understand this. Either you can take root 3 common, so 7 plus 6 will remain, that is 13 root 3 will be the answer. Or you can just add them, 7 and 6, because root 3 remain common. So 7 plus 6 is 13, so it will be 13 root 3. So this is how this is going to come. We have one more to simplify the surd form, that is root 20 minus root 5 whole square. So root 20 minus root 5 whole square. So root 20 can be written as 2 5s are 10, and 2 2 tens are 20, sorry, and 2 5s are 10. So it has 2 square and 5. So this 2 square 5 and 5 root can be written as under root 2 square and under root 5. This under root 2 square will be, because root is there, it will be 2 only, and this is root 5. So ultimately you get 2 root 5 minus root 5 whole square. But we know 2 root 5 minus root 5, if you take root 5 common from here, it will be 2 minus 1. I am taking root 5 common, it will be 2 minus 1, that is 1. That is root 5 only. And root 5 square is what? Root 5 into root 5 is 5. How? Because 5 raised to the power half into 5 raised to the power half of adds up, half plus half is 1. So it will be 5. Either way you do, it will be 5. Simplest surd form with fractions now. We have certain values with fractions. So root 75, let me write first root 75. So 75 can be written as what? See, 3. 3 2s are 6, 3 5s are 15, and 5 can be written as 5 5s are 25. So root 75 can be written as 3 to the raised to the power 1 and 5 raised to the power 2. This is root 75. That can be written as root 3 and root 5 square. Because this is root, so 2 will get cancelled. So you already know how we are going to do this. We have already done this. So 5 root 3. Now coming to this one, third root of 48. So third root of 48 raised to the power minus 1 is simply third root of 1 by 48, because everything which has power minus 1 goes to the denominator. Now 48, let us write 48. How can we write 48? It is 6 8s are 48, and you can write this as 2 3s are 6 and 8 is 2 into 2 into 2. So this can be written as 2 to the power 4 and 3 to the power 1. Okay, 2 to the 4, 4 to the 8, 8 to the 16, 16 3s are 48. So you can write 2 to the power 4 into 3 to the power 1. If you are taking say third root, then this 2 to the power 4 won't help. Actually, it is not like this. It is 1 by 2 to the power 3. I am writing this separately, then half and then 3. So this 2 to the power 4, this is 1 by 2 to the power 4, 1 by 3, because this is 1 by 48. I am taking 1 by 48. So now this third root, I am taking this separately. Third root of 1 by 2 to the power 3, and then third root of course, I am combining this 1 by 6. And then this can be written as 3, 1 by 2 to the power 3 and 1 by 3. 3 cancel, 1 by 2 will be there. And here I am taking third root in the denominator. So it will be 1 by third root of 6. So it will be 1 by 2 third root of 6. This is what we get. And here what we had, 5 root 3. So 5 root 3 into 1 by 2 3 root of 6. So what do we get? This one only, 5 root 3 by 2 third root of 6. This is what we get.